Working? Yes. Okay, thanks for the introduction. Hello, everyone. My name is Mete Atamel. As he said in Spanish, I'm a developer advocate at Google based in London. And I'm going to be talking about Istio Service Mesh. Before I start my talk, I'm curious, who was in my earlier talk in the morning? Okay, so you guys like the talk, I guess. That's why you're here. Well, this talk is very different than that other talk. The other talk was kind of fun way of building voice-driven applications and connecting them to Google Cloud. This talk is about managing microservices and how Istio can help for that. I think it's still kind of fun, but at the same time, it's very infrastructure-driven. So it's about running infrastructure, managing infrastructure, and how Istio can help with that. Before I start my talk, that's my Twitter. So if you want to get the slides, I already have versions of these slides on my Twitter, so you can just get the slides from there. This doesn't, let's see, this doesn't work. Yep. So please give me feedback. I think there's like a feedback application. So at the end of the talk, just give me feedback because I really appreciate all the feedback I receive from people about my talks. And as I mentioned in my previous talk, I'm doing a tour of South America, going to multiple countries. And as I go through the countries, I want to understand the developers in South America, what languages they use, whether they use cloud, if so, which cloud provider they use, so that next time I come here, I can do a better job of talking about stuff that's relevant to you. So if you have time, please fill that for me. It's only 5 questions. And by the way, don't let me forget, I have some Istio stickers. So if you stick around until the end of the talk, please come forward and I will distribute the stickers to everyone who's here. All right. Before we start talking about Istio, first of all, I want to provide the context for Istio because there's a lot of technology that's coming up every day, and trying to learn everything is overwhelming. So we have to be selective about what we actually learn. So first, I want to talk about containers, what containers provide and what kind of problems they solve. Then I want to talk about Kubernetes, which is a container management platform, and what kind of problems it tries to solve. And then I will talk about how they fall short and why the Istio project exists. Because without the context, I think it's kind of hard to understand what Istio is. So let's first talk about the need for Istio. Why do we even talk about Istio, and why should we even care about it? So before I start my talk, anyone here using containers or Kubernetes? So containers, so a few people. Anyone here using Kubernetes? A couple people? Okay. So for the rest of people, just quickly to recap, a container is basically a way to virtualize application. Just like virtual machines, back in the day, we used to have virtual machines where we virtualize the operating system and everything that goes on top of the operating system. With containers, we are virtualizing not the operating system, but the process and the dependencies of the process. And because what we are virtualizing is much smaller than the virtual machine, they are very easy to create, they are very easy to deploy, they are lightweight. You can have multiple containers running on the same virtual machine. You can easily share them, and they're composable, meaning, for example, you can have a base image that your application depends on. Then on top of that, you can build your own image for your own application with the dependencies and everything. And then someone else can take your image, and they can build their image on top. So things are composable. So because of all these benefits, containers became the de facto standard to package and run applications, especially in the cloud. And Docker gave us a way to use containers in an easy way. And there is this notion of Docker file in Docker where you define the contract for your application. In this Docker file, you define your dependencies, your environment, and your application. And Docker creates this context for your application and makes sure that this context is exactly the same whether you're running on your laptop or whether you're running in the cloud. So for example, in this case, we have a dependency on Debian latest image, and then we are installing some packages. So in this case, we're installing Nginx. We are exposing port 80, so that we are setting up our environment, and then we are running Nginx. So that's our application in this case. So in a single file, you define your dependencies, your environment, and your app, and Docker gives you that context, that consistent context that you need for your applications. But unfortunately, containers by themselves, they're not enough. Because when you run an application in production, you need redundancy, meaning you need to create multiple containers and you need to manage them somehow. You probably need to scale up and down. So if more people use your containers, you want to add more containers during the day, and maybe at night not many people are using your application, you want to delete some containers so you can save some money. You need to worry about service discovery. So how do people even find your containers, where they're running, and how do you expose your containers to the outside world? You need to worry about new versions of your application. So if a new version 2 of your application comes along, how do you update these containers to the version 2, and how do you do that in a consistent way? You probably also need to worry about configuration secrets. So how do you configure your app, and how do you get the configuration to your containers? So as you can see, there's a lot of problems that you still need to deal with. And containers, by just taking your app and containerizing it using Docker, doesn't solve these problems. So that's why we have Kubernetes. Kubernetes, it's a Greek word, as you can see with the Greek characters, that everyone mispronounces, by the way. The right way of saying Kubernetes in Greek is Kubernetes, but Kubernetes came out in the US, and people in the US, they tend to mispronounce things as they see fit, so that's what we have today. So even I mispronounce it now. But Kubernetes, it's basically one of the most popular open source container management platforms. It came from something called Borg. At Google, we've been running containers for more than 10 years, and we have an internal system called Borg to manage containers. We learned from it over the years, and we created Kubernetes for open source world. So we created Kubernetes for everyone else. And one of the biggest benefits of Kubernetes is that it runs pretty much everywhere. So it can run on your machine, it can run on Google Cloud, it can run on Azure, it can run on AWS. It's one of the rare technologies where you have major support from all cloud providers. So once you adopt Kubernetes to manage containers, you get to choose where to run it, right? It becomes basically your choice to figure out where to run it. And in Kubernetes world, what you do is first you containerize your application and put it in a container registry somewhere. And then you create what's called a pod template. A pod is the smallest unit that Kubernetes schedules. It can be a single container, or it can be multiple containers scheduled together. And then you tell Kubernetes what you want the world to look like. For example, in this case, we are saying replicas 3. So what that means is that we want to run 3 copies of these pods at all times. And Kubernetes looks at this, and then it uses the pod template, it creates your pods, and then it looks at the nodes that you have in your system. So these nodes can be virtual machines in the cloud, or it can be physical machines if you're running it locally. And it figures out where is the best way to schedule these containers and run them. And then once these pods are running, you can expose them to the outside world through something called a service. It's a Kubernetes construct, so you can think of it as a load balancer. And people from outside world will get to your service, and from there it will get to your pods. And at any point, if one of these nodes go down, Kubernetes will detect that right away, and it will reschedule, it will recreate and reschedule the pod. So in this world, basically, a microservice becomes a combination of what you create in your container and also what Kubernetes provides with replication controllers and services and stuff like that. But unfortunately, Kubernetes is not enough either, because when you run a service in production, you want logging. So what logging framework you should use, and where do you store your logs, and how do you visualize them? You probably want tracing. So how do microservices call each other, and where the time is being spent? It would be nice to know. It would be nice to do dependency visualization. So if a microservice A calls microservice B, and microservice B calls microservice C, it's nice to see that dependency, and it's nice to see how the traffic is flowing between those microservices. You probably want to be able to set policies on the traffic. So maybe microservice B can only be called from microservice A, but not from microservice C, for example, right? So you want to be able to set that policy, and you want to be able to apply that policy, and you want to be able to change that policy as you see fit, right? You probably want things like fault injection. So what happens when you add delay to your calls? Do your microservices behave the same way? Or what if there's an error, like in your calls? Do your microservices handle that error gracefully, right? So these are all the things that you still need to do. Some of the time we do them, some of the time we don't do them. But Kubernetes doesn't help for this. Kubernetes just helps with making sure that your container runs, scheduled and runs, but all these microservice level problems are still left up to you to handle, all right? So that's why we have Istio. Hopefully this kind of provided like the background for Istio and why it exists and why it's something that you should learn, because these problems that I mentioned here, they're not easy problems to solve. I mean, you can solve them in bits and pieces, but they're not so easy to solve. So it's good that we have a framework like Istio that will help with this kind of problems. All right, so Istio, what is it? It's another Greek word. I don't know why open source people are obsessed with Greek words, but the good news is that it's not mispronounced. It's actually Istio in Greek as well. And as I mentioned, it's just an open framework for connecting, securing, monitoring, and managing microservices. That's kind of what Istio is in a nutshell. So let's imagine that we have this kind of microservice cluster. So we have users talking to a front-end microservice. Then the front-end microservice is talking to a pictures microservice and a payments microservice. And since we need to authenticate, there's also an authentication microservice. And then at the same time, the payments microservice is talking to an external payment processor. So it's an external outside our cluster kind of service. And then we also have a backend for the authentication that keeps track of the user's username and passwords and stuff like that. So let's imagine we have this scenario. When you install Istio into this cluster, this is what you end up with. So a couple of things to note. First, you have public and private ingresses. So all the traffic outside of the cluster goes through something called ingress. So all the traffic is monitored coming into your cluster, and you can set rules on what happens as the traffic comes in. At the same time, all the traffic going out by default is blocked, and you have to create egress rules to enable them. So all the traffic is also going through egress if you want. If you don't want, you can also make things, make your microservices call directly as well, but usually it's a good idea to make sure that things are going through egress so you can set rules on it. So the traffic from outside and inside is kind of controlled. And then every container will also get what's called a proxy. And these proxies, they kind of live with the container. So as the container is created, these proxies are created, and all the traffic is routed through the proxies. So when the users want to talk to the front end, they will talk to the proxy of the front end. When the front end wants to talk to the pictures microservice, the proxy of the front end will call the proxy of the pictures, and so on and so forth. And because the traffic is routed through these proxies, Istio can come in and it can do a lot of interesting things, and that's what I'm going to talk about here today. So if you had to take a picture, I think this will be the slide. So if someone asks you, what is Istio? It's basically, this is it. You know, this is what Istio is. First of all, Istio works on Kubernetes, so you have to have a Kubernetes cluster, but it tries to be platform agnostic, so it tries to support things like Nomad and Mesos and Cloud Foundry. In reality, I haven't seen it support Mesos and Cloud Foundry yet, but that's the intention. The intention is that Istio is supposed to be platform agnostic. But as of today, it works on Kubernetes 100%. The current version is, I think they changed it now to 1.0.3 now, as of last week. But basically it just became 1.0 recently, and they keep incrementing it. And what it gives you is basically, first, observability. So by default, since traffic is going through proxies, these proxies, they emit what metrics, right? So the metrics are emitted automatically without you having to change the application code. Then you can visualize the metrics using Prometheus. So you can add on Prometheus very easily to your service mesh and query these metrics. Then you can add on Grafana as well to your service mesh and then visualize these metrics in nice graphs. And you can also see trace spans. So you can see how the calls are being made and how much time is being spent in these calls. So these trace spans are being emitted as well, and you can use things like Zipkin and Jaeger to visualize these trace spans. And finally, you also get dependency visualization, meaning you can look at your microservices and you can see who's calling what and how the traffic is flowing. So you get all these observability features for free. You don't have to change your code. You just install Istio, you get the proxies, and with proxies, you get these features. Then you get service identity and security, meaning all of your services will get strong identities, and they will have certificates, and all the traffic from service to service can be mutually authenticated, and the traffic can be HTTPS as well. And the details of this mutual authentication and HTTPS is handled by Istio. So Istio issues the certificates, and it can also update certificates when they need to be updated. So you get security by default as well. And finally, traffic management. So all the traffic, so you can think that, you know, Kubernetes manages your application and Istio manages your traffic. And it has a lot of features to, you know, set policies on the traffic and also change traffic flow dynamically as you want, right? So you can dynamically change traffic. You can set rules at the ingress and egress. You can do things like timeout. So by default, all the calls within the mesh, they have 15-second timeout, but you can change that. You can change the retries. So how many times a service should retry before giving up. So you can tell Istio, try this many times on behalf of your application without you having to do that in your application code, right? And you can also inject faults into your traffic management so that you can see that your service mesh is behaving the way you want it to behave. And yeah, the last thing is the policy enforcement. So all these policies that you set, they're enforced by Istio, so you don't have to actually do them in your application code, okay? So we'll now get into details of this and look at how they actually work. But this is basically what the whole talk is all about and what Istio is all about. So now, what do you need for Istio? First, you need a Kubernetes cluster. Anyone here using Google Cloud, by the way? No? Okay. By the way, there's a free tier in Google Cloud, so you can use it for free if you want. Just wanted to mention. But in Google Cloud, there's something called Google Kubernetes Engine. It's a way to get a Kubernetes cluster. And to do that is you would just run a gcloud command. So you would say gcloud container clusters create, give your cluster a name, hello Istio, then define your cluster version. In this case, I'm using the latest version of Kubernetes. I'm saying number of nodes. So these are the number of nodes I have in my cluster to schedule containers. And then zone is the zone that my application will run in this case, your west. By doing that, I get a Kubernetes cluster. And then once we have the Kubernetes cluster, all I need to do for Istio is to create a cluster role binding. This basically gives the permission that Istio needs to manage my cluster, okay? So once I do that, I have my cluster, and I can install Istio into it, right? So that's the only thing that you have to do. Get a Kubernetes cluster, and do this cluster role binding, and everything else will just work. So let me show you this. So first, first I should show you the Google Cloud Console. So here I'm in Google Cloud. I have two clusters. This is the Hello.NET cluster in Europe, and this is Hello Istio South America cluster that's based in Sao Paulo. I just created this because it makes my demos look a little bit better because latency between here and Europe wasn't that great. So I already created my Kubernetes cluster. I want to install Istio into this cluster. I just want to show you how that works. First, when you install, when you get Istio, this is Istio 1.0.2, there's an install folder, and under this install folder, there's some YAML files that you can use to install Istio. So that's what we'll do. So we'll just say kubectl apply, and then I'll say Istio Kubernetes, Istio demo auth. And as this is installing, now this will actually install Istio into our cluster. Fingers crossed. Yeah, now it created an Istio system namespace, so everything will go under an Istio system namespace, which is nice because if we want to uninstall Istio, we can just delete the namespace. And now it's installing all the components of Istio. But as this is happening, I want to show you the configuration. So this is Istio 1.0.2, and if you look at install, Istio demo. So there's two YAML files. One is demo, and the other one is demo auth. So between my services, I want mutual authentication. So for that, you had to use demo auth. But if you don't want mutual authentication, then you can use demo as well. And if you look at auth, this is, by the way, if you look at it, it's like a lot of lines. I think it's like 5,000 lines. But what it installs is that it installs everything in Istio, because Istio has many components that we're going to take a look at. And it also installs all the add-ons that you can have on Istio, like Grafana, Prometheus, and all that kind of stuff. That's why it's so long. You don't have to install Istio all at once, or you don't have to install any of the add-ons if you don't want to. But this demo YAML file is useful for me because I can show you everything from here. So that's why it's that long. Let's see how this is going. So now it's creating all the deployments, all the services. And as you can see, I think hopefully it worked. As you can see, this is just a regular Kubernetes pods and services and deployment. So there's nothing special here. So once this is done, what we can do is we can say kubectl get pods, but we won't see anything because Istio is installed under Istio system namespace. So we have to do this. And it's a little hard to see, but you can see that there's Grafana add-on. There's Istio Citadel for authentication is running. Egress gateway is running. This one is being created. and this one is completed. So most of them seem to be working. Let's see one more time. Yeah, all of them are either completed or running. I think this is still creating. So hopefully this won't cause any issues. But it looks like Istio, yeah, this one is also being created. But as this is happening, let's talk about other things, and then we'll come back to this. But that's how you install Istio, basically. Just point to a YAML file and pick and choose what parts of Istio you want to install, and it will just be installed on Kubernetes. All right. All right, now let's talk about the building blocks of Istio. So in a nutshell, this is kind of like the 3 and 4 components of Istio. So first, with every container, you have a proxy, and the proxies do the work of, discovering the other services and making connections to other services. These proxies, they're actually called something called Envoy. It's another open source project that came from a company called Lyft. And it actually exists as a separate project. So if you want to have just a proxy, you can use these Envoy proxies yourself. But Istio uses them as well because they're really nice proxies. And they can do HTTP 1.1, HTTP 2, and gRPC. gRPC, it's a binary protocol that came from Google, but it's also open source. And it's much more efficient than using HTTP 2 and JSON. So some people prefer to use that. So proxy supports all of that. And it also supports TLS, so you can have TLS, or if you don't want TLS, you can also choose not to have TLS. So proxies to take care of the connection. Then in Istio, there's 3 things: Pilot, Mixer, and Citadel. Pilot is all about service discovery and config management. So proxies, when they need to make a call to another proxy, they will ask, where is this service? And then Pilot will use the underlying platform to discover the service. So in this case, it will ask Kubernetes, where is the service DNS? And Kubernetes will tell Pilot, this is how you can find it. And then from then on, proxy will make a call to the other proxy. Similarly, if people want to configure Istio, they will talk to Pilot, and Pilot will take that rules that the user specified and apply them to proxy. So it will change those rules to the rules that proxies understand. Mixer is all about policy checks and telemetry. So when a proxy wants to call another proxy, it will ask Mixer, can I make this call? Because maybe there's a policy that prevents the proxy to make the call, or maybe there's a quota that's been reached, and because of that, the proxy cannot make a call to the other proxy. So Mixer keeps track of all of that. And also proxies, they emit metrics by default that I'm going to show you later. All those metrics go to Mixer, and Mixer kind of aggregates them, and you can look at them later. And finally, Citadel, it used to be called Istio Auth in previous versions of Istio, but it's all about authentication and TLS certificates. So it's the component that keeps track of the service identities, and it's the component that issues the certificates and rotates the certificates for the users. Okay? And as I mentioned before, you don't have to install all of this by default. You can, for example, if all you want is proxies and service discovery, you can just install Pilot, and you don't have to install Mixer or Citadel. If you don't care about authentication, mutual authentication, then you don't have to install Citadel. If you don't want metrics, you don't have to install Mixer. So you can pick and choose what you want to install. It's up to you, basically, to decide what you want. So that's what this slide is all about. Okay, so now let's make sure that our Istio installation is working. Hopefully it is. All right, so all of them are completed. That's a good sign. And what I want to show you now is that, okay, I have a simple application. How can I make this application, Istio ready? How can I deploy this on a Kubernetes cluster with Istio, and what kind of things I get out of it? That's what I want to show you here. First, one thing that we need to do is, if we do kubectl get, I have a cheat sheet here, actually. Let me just take a look. If you do kubectl get namespace Istio injection, so when the containers get created, if you want these proxies to be automatically created as well, then you need to set an Istio injection label into your namespace. So in this case, I have a default, there's a default namespace in every Kubernetes cluster, and I set this Istio injection label, and I enabled it here. And this will basically make sure that every time I create a pod in my default namespace, a sidecar proxy will also be created for that pod, so I don't have to create them manually. So that's what this is all about. And to deploy an app, I just created a Hello World ASP.NET Core application. And the first thing that we need to do is we need to first deploy this app in the Kubernetes cluster. And the way you deploy any app in Kubernetes is that first you create a deployment for it, and then you create a service for it so that you can expose it to the outside world. So I have this YAML file called ASP.NET Core v1. So let me just show you that first. So this is the Hello World app. And if you look at v1, you will see that first I have a deployment. So this is the deployment. That's the name of my deployment. I have some labels for my deployment, so I call it ASP.NET Core, and version is v1. And it points to an image on Google Cloud. So I already created this app, and I pushed the image to Google Cloud image repository. And then I'm also mentioning that this app needs port 8080. So that's my deployment. And then I also expose this deployment in a Kubernetes service called ASP.NET Core service that also has port 8080, right? So this is straight Kubernetes. There's nothing magical about this. There's no Istio yet. But first, we need to actually deploy this. So we'll say kubectl apply ASP.NET Core v1. And this will create the service and the deployment. And if we look at the kubectl get pods, there's pod initializing. And if we do get service, there's already an ASP.NET Core service that's been created. So we need to wait for the pod to be running. It's still initializing. But by creating this, we are not exposing it in Istio yet. What we need to do next in Istio is that we need to first enable HTTP traffic in Istio. And to enable HTTP traffic, we need to create something called gateway. And then once we have a gateway, we need to somehow link the Kubernetes service to the gateway, right? Because the gateway only understands the HTTP and port numbers, and your Kubernetes service is something else. So you need to make the connection somehow. And to do that, there's something called virtual service in Istio. In a virtual service, you basically do that mapping of, gateway to Kubernetes service. That's how you map them together. So let's see if this is working. Yeah, this is running now. And what I need to do is I need to say kubectl apply. So I will show you this gateway YAML. So this creates the Istio gateway, and I'm going to do kubectl apply virtual service. And this connects the gateway to the Kubernetes service. So if I actually do kubectl get gateway, I should see that there's a gateway. And if I do a service, then I should see that there's a virtual service. And to look at the code for this, so the gateway, this is, as you can see, it's using Istio API. It's not Kubernetes anymore. And the kind is gateway. And all we are saying is that expose HTTP on port 80 for all the hosts in my application, right? So we are basically exposing HTTP on port 80. That's what we're doing here. And then the other thing is virtual service. So in here, we are creating a virtual service that's linked to a gateway that we just created. And then the host here is ASP.NET Core service. So the host is actually a Kubernetes service. So that's how you basically map the gateway in Istio to a service, to a Kubernetes service running in your cluster. So by doing this, if we go back to here, and then if we do, let's look at the ingress kubectl get service Istio system. So in Istio, there's something called ingress gateway, and this is the IP. Actually, this is the IP. This is the IP of that ingress gateway. So this is the thing that's looking at all the incoming traffic. So if we open this up, and this is like, .NET Core application, .NET Core people will know this, but this is basically .NET Core. Now it's running on Kubernetes, and it's being managed by, its traffic is being managed by Istio now, okay? So that's how you can actually install an app and get it managed by Istio. And we already talked about this. So we already talked about gateway and virtual service. By the way, these things used to be called different things before. So if you use Istio before 1.0, they used to be called ingress rule, route rule, and things like that. But these are the new names. So gateway virtual service we talked about. Destination rule, it's basically rules that you can apply after the traffic gets to your service. And service entry is the rules that you can apply at the edge. So if you look at it as an example, gateway sits right after ingress and looks at, the protocol. So whether it's HTTP or HTTPS. Once you have that, you have a virtual service where you define the paths and which Kubernetes services you can map to. And then after that, it goes to destination rule that defines the different versions of your application. And then it's not in the picture, but you can also have service entry that where you can specify rules for outgoing traffic. Okay? All right, so now once you have Istio running, you can also install some add-ons. We already installed the add-ons because we installed the demo YAML file, and that installs Grafana and Prometheus and Jaeger and ServiceGraph by default. But basically, you can have Grafana to visualize metrics that's being emitted from Istio. You can look at Prometheus to actually search for metrics. You can look at ServiceGraph to see the dependencies of your application, so how the traffic is flowing in your system and who's calling what. And then you can use Jaeger or Zipkin to look at HTTP tracing, so where the time is being spent. Let me just give you an example of this. So what we can do here is that first let's send some traffic to our app. So I'm just going to run a couple of commands. Oh, sorry. So let's do this. So I'm just getting the ingress host and the ingress port, and then I'm going to set this to something called, you can see, gateway URL. And then what we can do is, let's copy this to send traffic. So now this is sending curl commands every second to my app, and it's returning 200, meaning that it's returning OK. And what I can do is, to look at these add-ons, I need to set port forwarding. So let's look at Grafana first. So I will open this one here. And now port forwarding is set. And then if we come back here and open localhost 8080, this opens up Grafana. And by default, we have some Istio-related dashboards. Let's look at Istio service dashboard. And it doesn't, not data points. For some reason, this doesn't work sometimes, and I don't understand why. But let me describe what should have happened. What you should have seen here is that Istio emitting metrics, and then this updates in real time, and you can see all the metrics of all your services displayed here, but something is not working. Let me look at another one. Let's look at Prometheus. That's for querying metrics. All right, let's go here. Now this opens Prometheus, and if I do Istio request, some of the metrics are missing. I don't know why, but you can see that there's already some metrics related to Istio that shows up in Prometheus because Istio is emitting them. Something is not quite right. I don't know. Maybe I missed a step. Not all of them are here. Let's see if we can take a look at Jaeger. So that's for HTTP traffic. For that, so this is the Jaeger, and it's telling me that this is some Istio spans, but I want to look at my ASP.NET Core application, and let's see if there's any traces here. So there's a couple. Yeah, there's something wrong with my app. It's not really showing me traces from my app, but there's a trace from the ingress gateway to ASP.NET Core that I can look at. But if things are set up correctly, you should be able to see traces from your application as well. So all these add-ons, like you can just add them on, and you don't have to change your code. As you've seen, I haven't changed my code. I just deploy my application. And because the traffic is being routed through Istio, you get all these like benefits for free. That's the point that I wanted to make it clear. All right. So I kind of showed the add-ons, but not quite. But hopefully you got the idea. And lastly, what I want to talk about in the last 8 minutes or so is the traffic management, because that's kind of like the heart of Istio. In Istio, so there's service discovery and load balancing by default. There's dynamic request routing, so you can basically set rules on how the requests are being routed, and you can do like A/B testing, or you can do like canary deployments and stuff like that dynamically on the fly. You can do failure recovery, so you can set how many, like what's the timeout for each call, and then you can set rules on like how many retries should happen in your calls, and Istio will do that on your behalf, so you don't have to change your application code to do retries. You can do things like circuit breakers and also fault injection, so you can inject faults into your traffic and see if your microservices behave the same way. And this fault injection, it can be faults, or it can be also delays, so you can make your calls like kind of slow and see what happens. So I can show you some of this, but just to recap, for example, if service A wants to make a call to service B, it will say, it will just make a DNS call, servicep.example.com. This will go to Envoy. Envoy will ask the pilot, where is the service? And the pilot will ask Kubernetes, where is the service? And Kubernetes will say, this is the service. But if you set a rule where you said, I want 99% of the traffic to go to version 1.5, but 1% to go to version 2, then Istio will do that, but the service A wouldn't know that. Like service A would just keep making a call to service B, but under the covers, 99% goes here and 1% goes there. So that way you can actually test out features and see how they work in production. Similarly, you can use headers. It's hard to see, but here you can say, if the user agent is Android, send it to this version of the service. If the user agent is iPhone, send it to this version of the service. And the service A doesn't know that, but it doesn't matter. Istio can set rules like that. And I mentioned the timeouts and the retries. You can limit the number of concurrent connections to your service. So you can set hard limits, and Istio will enforce that. And you can do circuit breakers as well. And fault injection is my favorite. So if you have two services with timeout 100 milliseconds, you can actually add a delay to your call, like 300 milliseconds, and see what happens. Similarly, if there's a timeout of 200 milliseconds, you can add a delay of 400 milliseconds and see what happens. You can even say, I want to return 400 error for 10% of the requests to the service V1, for example, and Istio will do that for you, so you can see how your service behaves. So let me show you this stuff. Hopefully this will work. First, I want to deploy a second version of my application. So to do that, I have another YAML called V1 and V2. Just to show you this. So V1 and V2, it's the same as before. So we have the service for the V1, the deployment of V1, but then I have another deployment called V2. So that's like the new code that I have. So we need to deploy that first. So I'll say kubectl apply, ASP.NET Core, V1, V2. Now this didn't change service and deployment, but it created a new deployment for version 2. And now, if I want to look at the new version of my application, what I need to do is first I need to create a destination rule for it. So let me just create that first, and then I will explain how it works. So I will do kubectl apply, ASP.NET Core, destination rule. So this created the destination rule, and then I need to update my virtual service to use this destination rule. So I will say kubectl apply, ASP.NET Core, virtual service, V2. So this updates the virtual service as well. And if we go back to our application, so now this is the V1 of my application. If I do update, this is the V2. it's like different color and less. So if I keep updating, it's the version 2. So what happened here is that the destination rule defines what's called subsets. So this says I have 2 subsets, V1 with these labels, and I have another subset, V2, with these labels. So these labels are the labels in Kubernetes, right? So we are basically exposing the Kubernetes labels to Istio using a destination rule. So once we have these subsets, what we can do is we can go back to our virtual service, and then in virtual service, we didn't have this before. So the host was ASP.NET Core service, but now I'm saying subset V2. So I'm saying, yeah, use this service, Kubernetes service, but only route to this subset, the V2 subset that I defined. So that way, if you roll out a new version of your application, you can just limit to that version. All right, so that's one. The last couple of things that I want to show is, let's see. So what if you want to route traffic so that you route 75% of the traffic to version 1 and 25% to version 2? You can do that. You just need to update your virtual service. So ASP.NET Core, virtual service, weights. So if I apply this is applied, and let me show you this in code. So if you look at the weights, in this virtual service, I'm saying that I have a route to version 1 of my application, and the weight is 75, and then version 2 of my application, weight 25, meaning 25% it will go to version 2. So if you go back to our application, and I do a refresh, now this is version 1, version 1, version 2, version 1, version 1, version 2. So you can see it's not quite 75%, but at least that's what it's trying to do. The other thing that you can do is, what if you want to do some faults in your service? So you want to return some errors in your calls and see how your microservices behave. So we can do that. We'll just say kubectl apply, ASP.NET virtual service, fault, abort. And what this does is fault abort. This says for my V1 of my service, for 50% of the traffic, so that's the percentage, return HTTP status 400. So half of the calls will fail with HTTP status 400, right? So that's what we apply right now. And if we go back here, and if we do refresh, now it's fault, 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 then my app, fault. So roughly 50% of the time we get some faults, right? And the last thing that I want to show is, what if you want to apply some delays in your calls and see how your application behaves? So for that, we can do kubectl apply, ASP.NET Core, virtual service, fault, delay. And if we look at the code here, delay, this says 100% of my traffic of the V1 version of my service, add a delay of 5 seconds, right? That's what we are delaying here. And if we come back here and do a refresh, now there's a delay. It's not the conference Wi-Fi, it's Istio delaying the call. And now you can see, if you do another refresh, it will be the same thing. It will just keep rotating for 5 seconds. So this kind of stuff becomes really easy. You can do it on the fly, and you don't have to change your application code. For me, that's the most important part, because this is just pure Kubernetes functionality. And I think that's all I have, but let me double check. Yeah, that's all I have. So if you want the slides, follow me on Twitter. If you want to do these steps yourself, there's actually a blog post I did back in August that shows you how to do it on Google Cloud. There's also a couple of code labs using .NET Core and Google Cloud and Istio. So if you're interested, the links are here. There's a Twitter for Istio called Istio Mesh. And finally, if you're a user of Istio, there's Istio-users Google group that you can join and ask questions about Istio. All right, that's all I had. Thanks very much.